Hello everyone, in this video let's talk about projectile motion. Projectile motion is actually motion in two dimensions. Consider an object which is thrown from a point A and it moves to point C, and the trajectory of the motion of the object from A to C is actually given by this black line from A to C. The velocity by which the ball is actually kicked is V, which is actually tangent to the path of the ball, and it is making angle theta with the x-axis. Now B is actually the highest point of the motion. Also keep in mind that whatever we are doing right now is actually in the absence of air resistance. The calculations which we will be doing, or the equations which we will use right now, is actually in the absence of air resistance. So we have ignored air resistance for the whole understanding of projectile motion. This will make understanding of projectile motion easier so that you can solve questions. Okay, so for simplified analysis of the motion, let us divide the journey into two sections, that is upward motion and the downward motion. Upward motion is from A to B and the downward motion is from B to C. Upward motion, which is from A to B, the velocity of the object is V at an angle theta, and Y is the maximum height, and X is the horizontal distance, or you can call it range. So A to Y is actually the vertical motion and A to X is the horizontal motion. So we have divided A to B, which is upward motion, into two sections, AY and AX. AY is vertical motion, AX is horizontal motion. As you can see, the velocity of the object is actually making angle theta with the x-axis, which means the effect of velocity is on both axes, x and y. So in order to simplify velocity in vertical and horizontal components, we have made vector triangle where V is the velocity, resultant velocity, Vx is the horizontal component of the velocity, Vy is the vertical component of the velocity, and the angle is theta. Now Vx is equal to V cos theta and Vy is equal to V sin theta by trigonometric ratios. If I take V as 15 and angle theta as 30, you will see that Vx is 13 meters per second while Vy is 7.5 meters per second, which means vertical velocity 7.5 meters per second is actually the velocity by which the object is moving from A to Y, and Vx is the horizontal velocity, which means the object is moving with 13 meters per second according to this example from A to X. Now considering vertical motion first, where u is initial velocity, you can find out u by V sin theta, and we have found it by V sin theta as 7.5 meters per second. So initial velocity according to this case is 7.5 meters per second u. Final velocity will be 0 because at maximum height the object will be at rest. Acceleration is minus 9.81 meters per second square. Air resistance is ignored, that's why the force opposing the motion will be gravitational force, and that force will have 9.81 meters per second square deceleration on the object. So acceleration 9.81 meters per second square. So we can use these equations. B is equal to u plus at, s is equal to ud plus half at square, 2as is equal to v square minus u square. The conditions for the use of these equations is the same as we have discussed earlier. The acceleration must be non-zero and constant, and the motion must be linear. As you can see, AY is the linear motion. From A to Y the object is moving vertically only. Now considering horizontal motion, which is from A to x, the velocity, horizontal velocity is 13 meters per second. And since there is no air resistance, so there is no force acting horizontally to affect the motion, so there will be no change to horizontal speed. It will remain same throughout the motion. Acceleration horizontal is 0, and you cannot use any of these equations for the calculation involving horizontal motion. So we can just use the equation of speed is equal to distance upon time, which is constant speed equation. Please keep in mind that the time taken by the object from A to B, or from A to Y, or from A to X is the same, because the object is only one. So if you find out time by the AY journey or AX journey, you will have the same time for AB journey or any path between A to B. So the time taken can be used for horizontal motion and can be used for vertical motion as well. Now if we talk about the downward motion, which is from B to C, I will see it as B to Y vertical motion, vertical downward, and C to Y or Y to C as horizontal motion. Because B to C is projectile motion, solving questions for this path is not easy. So we have simplified our calculation for BY and YC. Now I am making the vector triangle for the velocity. As you can see, this is the resultant velocity V, and this is Vx, and this is Vy. Now solving for vertical motion, which is By, initial velocity is 0 because at this point the object was at rest vertically. Now it has started moving downwards, so the initial velocity is 0, and the final velocity will be obtained by V sine theta. A is equal to 9.81 meters per second square, because the force, gravitational force, is now acting in the direction of motion, so it will accelerate the object. V is equal to U plus AT, S is equal to UT plus half AT square, 2AS is equal to V square minus U square. These are the equations which you can use for the downward motion, vertically downward motion, because the acceleration is constant and non-zero and the path is linear. Now for horizontal motion Cy, Vx is equal to V cos theta, and it will give you the same value as 13 meters per second if the velocity was 15 meters per second resultant velocity. So it will be same, and it will be same throughout the motion till C. Acceleration is 0 because there is no air resistance affecting the motion. V is equal to S upon T is the only equation which you can use here. You cannot use these equations for horizontal motion, and similarly you cannot use this equation for vertical motion because the object is accelerating. The time for the fall from BC, BY or CY is the same because the object is the same. If you find out time by any of the calculations, whether it is for vertical or from horizontal, you can use the time for the other journey as well. These are the concepts which will be required to solve projectile motion. In the next video, I'll be discussing some questions which will help you out in solving questions which are related to projectile motion. So please be updated, and please subscribe the channel so that you get updated whenever there is a new video uploaded. Thanks for watching.